Okay, today we're going to look at formulas in the form of fx is ax² plus bx plus c. So fx equals ax² plus bx plus c. And you guys know that this formula gives us a parabola, okay? But some of the information in the parabola is shown in the formula. And what we're going to start by talking about is a, okay? So this a here. All right, and you have done this already last year, but it will help you just to remember it. So the A tells us basically how wide the arms of the parabola are, okay? And that's a little bit strange. So I'm going to show you what I mean in GeoGebra. Okay, so this is GeoGebra. Some of you have seen it before. This is a program where we can graph functions and we can do things to them and see what happens. Okay, now what we have here is I have graphed a function of x². Okay, right now what we are looking at is just function of x is equal to x². And that's a parabola, looks like this. Okay, now you can see hopefully up here on the left in the formula, I've put an a in there, and up above it I've got a slider. And when I move that slider, that changes the value of a. Now, what I can do is we can make a higher. At the moment a is 1. If we increase a, you can see that the arms become closer and closer together of the parabola. Okay, so they become steeper. It's quite similar to with a linear equation. So the higher the a value, the steeper the arms are. Okay, but what's going to happen now if so this was where we had it nice and steep. As you open it up, you can see that the arms become more and more open. Now, what happens if we go below 1? Well, you can see here we're at 0.35, 0.3. The arms are getting wider and wider. Okay, 0.1, 0.05. When we get to a is 0, what's actually going to happen is there is no x² term. So we end up with a straight line. Okay, because if a is 0, then fx is equal to 0. Okay, if we now go below 0 for our a value, then the arms start to curve back down again. Okay, and the same thing happens as before. And you can see that they're becoming more and more steep, but now in a negative direction. Okay, so then now they're going down. Okay, and the higher, or sorry, in this case, the lower the value of a. Okay, so as we make it bigger and bigger. So now we're down to -2, -3. You can see that the arms are becoming more and more steep, but now they're facing downwards. So basically the a tells us how the arms are shaped on the parabola. Okay. Now, the nice way of summarizing this, if we go back to this, is that if a is greater than 0, then our parabola looks like this, okay? And the way I see it, we call a here, a is positive. Okay, a is positive. For me, positive people, usually they're happy people, and happy people smile. So we have a happy parabola. Okay, if a is less than 0, then it's a is negative. Okay, so if a is less than 0, then a is negative. And negative people are sad, so we'd say sad parabola. Okay, and that means it looks like so. And I think that this is a much clearer way of thinking about it. If you just think positive, a is positive, positive people are happy, so it's a happy parabola, it's smiling. Okay, a is negative, it's a sad parabola, therefore the parabola is frowning. Okay, the other thing you need to get out of this section is that when we have a parabola, the parabola also has this important feature. Okay, if we make an axis and we draw a parabola on that axis, okay, we have a few features, all right? One of our features is that the parabola has, firstly, x-intercepts. So these are the x-intercepts. And then in the case of this parabola here, we have 2. So these are x-intercepts. Okay, our parabola also has here with this blue point, this is a y-intercept. Okay. What they also have is this beautiful line down here, and this is what we're going to look at now. So this here is what we call the axis of symmetry. And there's two features of the axis of symmetry. Firstly, it is halfway between the x-intercepts. Okay, so if you want to know the value of the axis of symmetry, then you can just find the average of the x-intercepts. Average the x-intercepts, and I'm going to write this in shorthand because I don't want to write it all down. So average the x-intercepts, that will find you the axis of symmetry. Okay, but the other feature of the axis of symmetry is that this point here lies on it, and this point here is what we call the vertex. Okay, and we will do a little bit more with the vertex later, but once you know the axis of symmetry, so if you know that this is 2, for example, you can just substitute 2 into your formula to find the value of the vertex. Okay, so the axis of symmetry is halfway between the x-intercepts. It's halfway between any 2 points at the same height. So for example, if we know, let me pick another color here. If we know that we have a line, a horizontal line going like this, and let's say that we know the value of these 2 points here, then the axis of symmetry is exactly halfway between those 2 points. That's what symmetry means, that you have a reflection that's the same on both sides. So if you know the value of the parabola at a certain height for 2 points, then again, you can just find the average of those to find what that axis of symmetry is. So as an example, if we have a function like y equals, or I should use function notation, fx equals x² plus 2x minus 15. Okay, let's say that I wanted to know the value of the vertex. All right, the vertex of this is on the axis of symmetry, and the axis of symmetry is halfway between the x-intercepts. So the first thing we need to do is find the x-intercepts. Okay, and we do that by finding where y equals 0. So we always let y equals 0 to find the x-intercepts. So that means we have 0 is equal to x² plus 2x minus 15. Now we can just solve this to find x. All right, now if we solve this one, we know we can factorize this. Okay, 2 numbers that multiply to give minus 15 and add to give plus 2. Well, it's 5 and 3, so we have plus 5 and minus 3. If you find that difficult, please use a table, which means that x plus 5 equals 0, or x minus 3 equals 0. X is equal to minus 5, or x is equal to 3. Okay, so these are our x-intercepts. Now, in order to find that axis of symmetry, we need to find the average of these, because remember, it's halfway between them. So axis of symmetry is at minus 5 plus 3 divided by 2. What's minus 5 plus 3? Well, that's minus 2 over 2, which equals minus 1. So we know that our axis of symmetry is at minus 1. If I said to you, therefore, I want to know the vertex, well, the vertex is the f of the axis of symmetry. Now, we actually call this the f of the x vertex. Okay, so the name of the axis of symmetry is the x vertex. We'll use subscript to write that vertex part. So we have the function of, in this case, minus 1. Okay, so the f of minus 1 for this formula was, we have x² plus 2x minus 15. You can actually also substitute it into the factorized form, so let's do that for something different. We have minus 1 plus 5 minus 1 minus 3, because actually usually it's much nicer and easier to do it this way. Now you don't have to expand the brackets here, because remember in BIMDAS, okay, the first thing is B for brackets, so just do what's inside the brackets. So minus 1 plus 5 is 4, and minus 1 minus 3 is minus 4, so it's just 4 times minus 4, which is minus 16. Okay, so that means our vertex is at minus 1 minus 16, and that should be our vertex for this parabola. Okay, now the vertex is different depending on whether it's a happy or a sad parabola. Okay, if it's a happy parabola, then the vertex is a minimum. Okay, it's a minimum value, it's the lowest point. Okay, if it's a negative parabola, a sad parabola, then the vertex is a maximum. Okay, so this is what we want you to get out of this section of the work. All right, so just knowing what A means and knowing how to find the vertex by looking at the axis of symmetry. Okay, it's a few steps to get there, because you do have to find those x-intercepts first, but it's actually quite nice to do. And as I said, it doesn't have to be the x-intercepts, just a horizontal line where we know that the values of x are the same, the values of the function are the same. Okay, so good luck with that.